Section 7.4, Trig Identities. Now the first trig identity I'm going to give you is this one here. So it says to either verify the identity or establish the identity. So the identity I'm giving you here is secant of theta times the sine of theta equals tan of theta. So when we want to verify or establish an identity, essentially what we have to do is we have to start from one side using trig identities or algebra to make it look like the other side. So for instance, with this identity here that we're going to verify or establish, I can write it this way. So secant of theta, if we remember, is equal to 1 over cosine of theta. And essentially all we're doing is replacing it. So we're doing substitution, and that's times the sine of theta. Now if I'm multiplying fractions, and you see on the left the 1 over cosine is like a fraction, that's going to be 1 over cosine of theta. And with any number I'm multiplying by it, I can put a 1 underneath it. So that's sine of theta over 1. So now, how do I multiply fractions? Essentially, I just multiply straight across. So then this is actually going to equal sine of theta over cosine of theta. And if you remember your identities, we know the sine of theta over the cosine of theta equals the tangent of theta. So that's the end of this one here, because it actually now equals the other side. And all we used here was substitution, trig identities, and algebra in order to accomplish this. So there's our identity. So again, we start with one side using algebra, substitution, and identities to make it look like the other side. Okay, so now our next example we're going to do is, this one's going to be a little more interesting. 1 minus sine of theta, okay, plus 1 over 1 plus sine of theta equals 2 secant squared theta. Okay, now this one definitely is going to be a little more interesting than the last one we had, because when I look at this one here, essentially what we have to do here is we want to start with a more complicated looking side. And by looking at this one, it's going to be the left one. So it's going to be over here is where I start. All right, so what I'm going to do now is I'm going to take this one, and essentially I want to add this together here. Okay, so what I'm going to do is in order to add those together, I need like denominators. So essentially, what am I going to have to do here is I'm going to have to take this first one here, and times it by the top and the bottom by 1 plus the sine of theta. And then this one here, I'm going to have to multiply this one by 1 minus sine of theta. So again, if I multiply the bottom by that, I'm definitely going to have to multiply the top by the same thing. So I do the same thing for both of these. All right, and what I get here, if you look at the bottom here, it's a FOIL. So on the top, I'm going to get 1 plus sine of theta. And then on the bottom, when I do this multiplying out, it's going to be a 1, and then it's going to be a plus sine of theta. And then I do the second term, and I multiply that through, and that's going to be minus the sine of theta. And then the last one there, it's going to be minus sine squared of theta. So that's that first piece. And then one thing you'll notice here is the two middle terms, when I when I actually work these out, those cancel out. And then for this next one, we're just going to write out what the answer is for this. So this is just going to be 1 minus sine of theta over 1 minus sine squared theta. And then when I fix this side on the left here, this is going to be 1 plus sine of theta over 1 minus sine squared of theta. And then when I put those together, that's what I get. So then I'm just simply going to add those together now. Since they have the same denominators, I can add the numerators. And I'm actually going to get 2 over 1 minus sine squared of theta. Now there's an identity that we know, or may not know, or remember, but it's this identity here. It's called a Pythagorean identity, and it's called cosine squared of theta plus sine squared of theta equals 1. And if I move this around a little bit, I can get cosine squared of theta equals 1 minus sine squared of theta. And then that tells me here, then I can actually just do a nice substitute here in for each of for this bottom here. So then I can say that this equals 2 over cosine squared of theta. Now from here, I can also write it this way, 2 times 1 minus cosine squared of theta. Now, normally it's like, hey, why would I do that? But here I'm looking at what I'm supposed to get. And if you look at here, I'm supposed to get 2 secant theta, secant squared theta. So therefore, that's why I moved it around this way. So this is actually going to equal 2 secant squared theta, because 1 over cosine of theta is equal to secant theta. So this is our identity that we're using here. Okay, and then from there, you notice we ended up with the end result using algebra, identities, and substitution to achieve the other side.